is equal to 2x squared minus 1 all over x squared plus 3, right? Is that right?
Yeah.
Right. So it says find the horizontal and vertical asymptotes. Use limits to describe the corresponding behavior. Where do the vertical asymptotes come from? Well, the vertical asymptotes come from the fact that the denominator, in this case, x squared plus 3, cannot equal 0. So algebraically and analytically, I'm going to say x squared is equal to negative 3, or x is equal to, wait a minute.
Square root negative
Can't
3.
do square root.
Why? It's a square root of 3i.
Yeah, but you can.
So it's plus or minus, right?
So there's no vertical asymptote.
Well, we're going to see. We're going to graph this in a second and talk about it. Okay? All right. So it's plus or minus. I forgot to write down the minus. Okay?
Let's get first one.
It is.
Now, for the horizontal asymptotes, we're talking about end behavior. Now, here's an interesting thing. Well, when we talk about horizontal asymptotes, asymptotic behavior, we're really talking about the limit of a function as that function approaches infinity and the limit of the function as x approaches negative infinity. Okay? So now, when we approach infinity, that's x approaching a very large number. So just think in your head, if I go and I let x equal 10 million, the value in the top will be 2 times 10 million squared minus 1. All over 10 million squared plus 3. Does that minus 1 or plus 3 have a major impact on the ratio? No. So really, when it comes to rational functions and we talk about end behavior, we only are concerned with the leading terms of the numerator and the denominator. And I want to clarify what I mean when I say leading term. It has to be written in descending order. It has to be the highest power of x in the front, and then all of the descending powers of x behind. And then really, everything else is insignificant. So we could think of this as a function like 2x squared over 1x squared. The asymptotic behavior of this rational function, f of x, will be almost identical to g of x. We could toss everything off, everything after the leading term aside, because we're plugging in such big or such small numbers. Now, what do you notice about this?
It cancels out to 2.
Yeah, it's just 2. It reduces down to 2. So what do you think the y value of this would be?
2.
2. What do you think the y value of this one will be?
2.
2. Now, how can we double check?
Graph. You could substitute in for.
We got to graph it. Okay, we're going to graph it. So we're going to graph it, and so what I'm going to do, and so that was the quantity 2x squared. What was it? The rest of
2x
it?
squared minus 1 all over x squared plus 3.
Bless you.
Plus you.
Thank you.
Welcome.
Was it plus 3? Yeah.
Yeah.
All right. So now let's graph it and see what it does. Oops, I gotta go. Let's adjust the thing here. Huh? What did I do wrong here?
Yeah, that's what mine was doing yesterday.
Well, it's you gotta set up the values. So
Zoom to
Wait, if you go.
go zoom 6. No, not 6. Zoom fit.
hold on.
9. Yeah.
It says check the arguments.
I got mine to graph.
Oh, I have one too many closed parentheses, that's why. You see that on the end?
That really won't mess it up.
What do you think?
Well, I mean, I put it in with like the cosine before and I had that extra parentheses with the cosine and it didn't do anything before.
Well, it's working now.
Oh.
All right. So now somebody correctly stated, and I wanted to hesitate. I wanted you to think about it. Somebody correctly stated there are no vertical asymptotes. Why? Because there are no restrictions in the domain. So it's all real numbers, right?
Yeah.
So there is asymptotic behavior, and we said that as we approach negative infinity, this value here should be 2. In other words, the limit of f of x as x approaches negative infinity should equal 2. Likewise, we said that the limit of this thing as x approaches 2, or positive infinity, I wrote that down wrong, positive infinity should equal 2 as well. And then we said that g of x, which was 2x squared, remember this stuff, g of x, which is 2x squared over x squared reduces down to 2. If I graph y equals 2, because that's what that reduced down to, I'm just going to plug the 2 in, don't worry about the scribbles. Look at what that red line does. See how that works? Now, one last thing, if I wanted to verify that, I could say, let's let x equal -5. Guess what? Oh, darn it. I did the wrong thing. I said -5. Let's let x equal -5. And it starts to approach 2. See how that starts to approach 2? As we go. And then if I let x equal 5, positive 5, and we keep going in this direction. So it's already pretty close to 2 before I get to like x equals 10.
So what would you call that thing that's like?
It's just the behavior of the function. It's nothing fancy. There's no fancy name for it. Okay.